And then we come to the convex mirrors. In convex mirror, we will try to first understand how the image is formed, how the ray will travel, the basic traveling of the ray as we have first seen in concave mirror. So, if you have a convex mirror now, its center of curvature will be here, its focus will be here, its pole is on the other side. And when a beam of light is incident parallel, it will appear as though it is coming from focus. So this reflected light will appear as though it is coming from focus. And also, you know, the line that you draw from center of curvature will actually break it into two halves. So a parallel beam of light will reflect from the surface of a convex mirror and it will appear as though it is coming from focus. Second, if you take a convex mirror again and this is the pole, this is focus, this is center of curvature, and a beam of light is along center of curvature, is towards center of curvature. So here the angle of incidence will be 0, angle of reflection will be 0. It is going to retrace its path. So if a beam of light is made incident towards center of curvature, it is going to retrace its path. So these two basic rules in formation of image in a convex mirror that you will keep in mind. Now let's draw an image. How the image is formed in a convex mirror. So you have a convex mirror this time. यहाँ ज़्यादा examples नहीं है. Like in concave mirror, you are having so many situations, 6 situations. In convex mirror, not many situations. Even one ray diagram will be enough for understanding all cases of convex mirror. So here, just imagine that I think I have made focus a little early. So the gap is not exact. So I make it here, focus. So pole, focus and center of curvature, they should be equidistant. So I keep an object AB in front of it. Let's see how the image will form. First ray, incident parallel. अब ये कहाँ जाएगी? Parallel incident हुई है, तो it will reflect, but it will appear as though it is coming from focus. अब second beam क्या होगा? Second beam ये आएगी. At an angle say theta, it will reflect back at the same angle theta. And as a result, you will find the image A dash B dash here. तो आप देख सकते हैं. अब मैं आपसे पूछता हूँ, इमेज बताइए रियल है या वर्चुअल है? तो आपका आंसर होगा वर्चुअल, बिकॉज इट इज फॉर्म्ड बाय apparent meeting of the rays. Is the image erect? Yes, the image is erect. If the image diminished or enlarged, so your answer is the image is diminished. तो आप देख सकते हैं प्लेन मिरर में वर्चुअल इमेज सेम साइज थी, कॉन्केव मिरर में वर्चुअल इमेज एनलार्ज थी और कॉन्वेक्स मिरर में वर्चुअल इमेज of smaller size. And then let's talk about u. अगर मैं u कहूंगा तो u की वैल्यू आएगी -x. Say it is x, so I write it -x. अगर मैं आपसे कहता हूं v, तो v की वैल्यू आएगी +y. अगर मैं आपसे कहता हूं मैग्निफिकेशन which is -v/u, तो -v की वैल्यू y, u की वैल्यू -x, so it is y/x. So magnification is less than +1 because y is obviously smaller than x. तो ये वर्चुअल होगा, पॉजिटिव मैग्निफिकेशन शो करता है कि वर्चुअल इमेज बनेगी, और लेस देन 1 शो करता है कि द वर्चुअल इमेज विल बी स्मॉलर इन साइज एज कंपेयर टू द ऑब्जेक्ट साइज. So that's how we can see the case of convex mirror. अब यहाँ एक चीज और देख सकते हैं, जैसे जैसे आप इस ऑब्जेक्ट को पास लेके जाते हैं, सपोज आप इस ऑब्जेक्ट ए बी को यहाँ ले आते हैं, तो क्या होगा, ये एंगल बढ़ जाएगा, ये एंगल इंक्रीज हो जाएगा, और उसकी वजह से जो इमेज आएगी वो इधर आ जाएगी. इसका मतलब जैसे जैसे हम ऑब्जेक्ट को पास लेके जाएंगे, as the object is moving towards the mirror, the image is also moving towards the mirror and is getting bigger. But in any case, the virtual image will be of smaller size than that of object. अब आप समझा सकते हैं कि ऐसा क्यों होता है कि बैक व्यू मिरर जो आपका व्हीकल होता है, सपोज कार में जो बैक व्यू मिरर होता है, it is preferred to be a convex mirror. So why the back view mirror in the car has to be a convex mirror? तो उसको आप समझ सकते हैं कि suppose you are talking of a back view mirror. Say I take this as a back view mirror and say I have a truck just in front. I would like the truck is of big size. तो एक ट्रक जो सामने से आ रहा है उसकी साइज बहुत बड़ा है, मैं चाहता हूं, और मैं इस मिरर में देख रहा हूं. While looking into the mirror, I want to see the image of the truck. It means I want a virtual image. तो पहली बात, बैक व्यू मिरर में हमें चाहिए वर्चुअल इमेज, जिससे कि हम मिरर में देखें और हमें इमेज दिखाई दे जाए. दूसरी बात, द ट्रक इज ऑफ सच ए ह्यूज साइज and there are so many other vehicles on the road. So all those vehicles, if the exact image we would see, तो हमें एक या दो व्हीकल से ज्यादा दिखाई नहीं देंगे, पूरी रोड नहीं दिखाई देगी. But in case if we are using a convex mirror, then the virtual image will be smaller size. Virtual image will be of smaller size. It means this convex mirror will be able to locate many of the images which are on the roadside. तो पहली एडवांटेज होगी, आप मिरर में देखेंगे आपको इमेज दिखाई दे रही है ऑफ द थिंग्स बिहाइंड. सेकंड होगा कि जो भी चीजें आपको रोड के ऊपर आपके पीछे हैं, यू विल सी द स्मॉलर इमेज ऑफ देम ऑन द mirror so that you can see most of them. So, and third, as the object is coming closer, the virtual image will keep getting bigger and will also show you coming closer. So you can always check कि कोई इसमें से जो पीछे से व्हीकल आ रहा है, इसमें से कोई अगर व्हीकल आपके बहुत क्लोजर आ रहा है, its image will keep getting bigger. And also in the mirror you will see it is coming closer to you. So due to three reasons. Number one, it is giving a virtual image. Secondly, it is giving a smaller virtual image. And thirdly, as the object is coming closer, the image is also coming closer and getting bigger. Due to these three concepts, due to these three properties which you see in the virtual image of a convex mirror, it is preferred to use it as a back view mirror. So this was the case of a convex mirror, and now we can see. So let's see the uses of convex mirror. Convex mirror is used as a reflector in street light. So just imagine you have a street light somewhere, and then the convex mirror is there. The convex mirror will reflect these light beams and will, lighten up more area of the light from the source. Convex mirror is used as rear view mirror in automobile. मैंने आपको बताया ऑटोमोबाइल में रियर व्यू मिरर क्यों यूज करेंगे, बिकॉज इट प्रोड्यूस इरेक्ट इमेज, इन्वर्टेड इमेज नहीं बनाता है. द साइज एंड वर्चुअल इमेज, द साइज ऑफ द इमेज इज स्मॉलर and thus it covers wide range. The images are found between pole and focus, and as the object is coming closer, the image is also coming closer. The convex mirror are also used as safety viewers at dangerous corners and sharp turns. आपने देखा होगा कभी कभी sharp turn है, अगर तो यहाँ पे हम एक convex mirror लगा देते हैं over here, so that if the vehicle is coming from here, then the person over here can see this vehicle, can see the virtual image of this vehicle. So the convex mirrors are used at the sharp turns if you are going on the mountain road or at any such position where there are sharp turns. Convex mirrors are used to help you at those dangerous turns. So these were examples, and I hope you have learned very well the image formation in concave mirror and convex mirror. Now it is a question of just practicing by your own. आप व्हाइट पेपर लीजिए, उसके ऊपर कॉनकेव मिरर, कॉन्वेक्स मिरर के डिफरेंट पोजीशन में इमेज बनाइए, रे डायग्राम बनाने की कोशिश कीजिए, एंड आफ्टर 1 or 2 प्रैक्टिस यू विल फाइंड योरसेल्फ कंफर्टेबल एंड परफेक्ट. So dear children, now after taking all the cases of image formation in concave mirror, convex mirror, all possible locations of image and the object, real and virtual images, you are in good position to understand the mirror formula and utilize that mirror formula in various situations. This mirror formula, as it suggests, it's a formula which is applicable for all mirrors, concave mirror, convex mirror, even plane mirror, and for all position of object, real image or virtual image. So it's a formula which is available, which is actually a formula for all the mirrors, and this formula is 1 by u plus 1 by v is equal to 1 by f. You know very well u, v and f now. And then there is one more formula that we will try to prove, and that is formula for magnification. So this mirror formula, first I will prove it for concave mirror, then I will prove it for convex mirror, just to have a confirmation that it's the same formula in case of all mirrors for all position of objects. Now, in order to prove mirror formula in concave mirror, I have taken a concave mirror. This is the principal axis, pole, focus, center of curvature. And let we have an object AB over here. The first ray which I will take is, let this ray fall at point P at an angle theta. The angle of reflection will be same. So you have a reflected ray here. And the second ray choice, which is my choice, is let's take this ray parallel to the principal axis, and after reflection it will pass through focus, and thus it has given you an image A dash B dash that is formed between focus and center of curvature. Now, in order to prove the mirror formula, one key line, I will say one key line, lens formula ho ya mirror formula ho, this key line you remember, and that is take two pairs of similar triangle. So you take here two pairs of similar triangle. अब देखें similar triangle कहाँ है? Can we see two pairs of similar triangle here? The first pair of similar triangle, if you can see in this figure, is, I can say, A, B and P. It is making an angle theta. A, B, P. It is making an angle theta. Second is A dash, B dash, P, it is also making an angle theta. So this is one pair of similar triangle over here as well as here. These are two similar triangles. And in this pair of similar triangle, I will write A dash B dash, the ratio of all angles are same. That's why the ratio of all sides will be same. So A dash B dash by AB is equal to PB dash by PB. So this is my first take. In these two pair of similar triangle ABP and PB dash A dash or A dash B dash P, I can say because all angles are same, all sides are also in the same ratio. Now let's take another pair of similar triangle. Let's try to look at another pair of similar triangle. This is F. If I call this time, for a moment I am just removing this ray that helped you earlier. So in this another pair of similar triangle, can you see? And I am drawing a line from here which is MN. So can you have a look at another pair of similar triangle? This is phi, then this is also phi. So another pair of similar triangle, if I can see, it is A dash, B dash and P and F making an angle phi. And similarly on the other side it is, I can see angle phi, it is F, N and M. In fact, this MN is equal to AB. So whenever I write MN, I can also write AB here. We can also write AB here. So in this, as the sides, as the angles are same, the sides will be in the same ratio. So I can write here A dash B dash by AB. A dash B dash by AB or MN is equal to B dash F, B dash F or FB dash divided by NF. But this NP is negligible and all distances are measured from pole. So we better write this B dash F divided by PF instead of NF. So you can see the results that we have obtained. The results that we have obtained now, I can write them separately. First, let's make a space here. And the results that we have obtained is A dash B dash divided by AB is equal to PB dash divided by PB, equation 1. And also A dash B dash divided by AB is equal to B dash F divided by PF. This is equation 2. And I will draw back this line just for your convenience so that you can always recall it was same angle theta. Now compare this equation 1 and 2. What we get? PB dash by PB is equal to B dash F by PF. Now how much is PB dash? आप इस distance को क्या कहेंगे? PB dash. What you will call it? It is minus V. What you will call it? PB. If I say how much is PB, तो आप इस डिस्टेंस को क्या कहेंगे? PB. So your answer is minus U. Now if I take what you will call this distance, B dash F, ये distance. What you will call this distance, B dash F. यहां से लेके यहां तक तो V था और यहां से लेके यहां तक F है. तो B dash F should we call it minus of V minus F? Because it is minus V minus F. Both are already negative. So it is basically magnitude wise it is V minus F and both are towards left side. Pole से चलेंगे opposite to incident ray जा रहे हैं तो both have a negative sign. And then PF, ये PF, what this distance will be called as minus F. So you have finally the relation V by U is equal to V minus F by F. Let's do the cross product. You will get VF is equal to UV minus UF. And let's divide it by UVF. तो यहाँ क्या आएगा? 1 by U. यहाँ क्या आएगा? 1 by F. यहाँ क्या आएगा? 1 by V. So as a result, finally, we are getting 1 by U plus 1 by V is equal to 1 by F. So this is the mirror formula you have obtained. और अगर मैं इसको recall करता हूँ तो important था, you have drawn the figure and then you just thought of, let's take two pairs of similar triangle. So you took two pairs of similar triangle and then it was very easy to compare because their angles were same, their sides will be in the same ratio, and then you have compared them. So you can find 1 by U plus 1 by V is equal to 1 by F. And let's look for the magnification now. And for magnification, I'm using one of these equations that we have received. For magnification, I use, say, equation 1. Equation 1. A dash B dash by AB is equal to PB dash by PB. What is A dash B dash? A dash B dash is minus I. And what is AB? It is plus O. And what is PB dash? It is minus V. And what is PB? It is minus U. So, we have this relation. I can say minus I by U is equal to V by U. But just remember, in mirrors, we'll use this relation as I by O is equal to minus V by U. In this form, we are going to use it. So this minus sign we will keep along with V by U, with not with I by U. This will help you a lot. So as a result, what I have obtained is, in the mirrors, the relation 1 by U plus 1 by V is equal to 1 by F, and also magnification I by U is equal to minus V by U. So you could prove the mirror formula, and it was the mirror formula in case of concave mirror. And just two rays are enough to form the image. और ये जो choice of two rays है ये बड़ी important है. It will help you a lot. मैंने कहा पहली रे मैंने point pole के ऊपर ली है, which is making an angle theta and reflecting at an angle theta, and another ray parallel to the principal axis. You can take another ray passing through focus and then getting parallel. It is your choice, but you can try on your own, taking it between using different pairs of rays and forming the image. So this is spherical mirror formula for concave mirror. Now let's take in case of a convex mirror. It is just for your confirmation that the formula remains same irrespective of real image, virtual image, concave mirror, convex mirror, the mirror formula is same. So let's take the second case, and that is, so let's take this mirror formula in case of a convex mirror. The result should be same, 1 by u plus 1 by v is equal to 1 by f. In case of convex mirror, the only thing is you have a virtual image. So here is the convex mirror, here is the principal axis, this is pole, this is focus, this is center of curvature. You are keeping an object AB here. My first choice of the ray will be this one, reflecting at the same angle theta, and it appears to come from somewhere here. And the second choice of the ray, let's take a beam parallel and it will pass through focus. It will appear to come through focus and is actually going here. So as a result, you are getting this image here, A dash, B dash, virtual image. And you can recall, if this angle is theta, then over here this angle is also theta. So as we do it, let's take two pair of similar triangle. So we are looking for two pairs of similar triangle. So one pair of similar triangle I can see here, and it is ABP, making an angle theta, and also A dash, B dash, P, making an angle theta. For your convenience, I make it like this. This is A dash, B dash, P at an angle theta. So you have taken this one pair of similar triangle, and in this pair you can always write, because all angles are same, ratio of arms will be same, A dash B dash by AB is equal to PB dash. Better call it PB dash rather than B dash P, because all distances are measured from pole, by PB. Now let's look for another pair of similar triangle. In order to have a clear idea of another pair of similar triangle, I am withdrawing this line, and you can see on the right side it is clearly visible the other pair of similar triangle. And for that, what I need to do is to make another pair of similar triangle, I assume here one more line, and that is MN. You know this NP is negligible and MN is equal to AB. Let's take this angle as phi. So if we look for another pair of similar triangle, I will say this is F, this is N, this is M, this is A dash B dash. This angle is phi. So MN and AB, they are same. And similarly, N, instead of NF, I can always call it PF. So this point MN can be also taken as P, because NP is negligible. So here I write the second one as MN divided by A dash B dash. We should call it A dash B dash, similar way, by MN. So A dash B dash by MN will be equal to B dash F divided by NF. And this A dash B dash MN can be said as AB, and it is B dash F, and here it is in NF can be called as PF. So we have obtained two relations. The two relations that we have obtained, I am writing it here. A dash B dash by AB is equal to PB dash by PB. And second is A dash B dash by AB is equal to B dash F by PF. And now we can go further to finally get the mirror formula and the formula for magnification. And for that, equation 1 and equation 2, we can write PB dash divided by PB is equal to B dash F divided by PF. Now, how much is PB dash? This value, PB dash, is plus V. And how much is PB? It is minus U, opposite to incident ray. Now, how much is this B dash F? B dash F. So, this whole distance is F, but B dash is V. So, it will be plus of F minus V. We are looking for this gap only, B dash F. So, it is whole distance F minus V. And let's call it PF. P to F, it is plus F. So, let's do the cross product. FV is equal to minus UF plus UV. Let's divide it by UVF. So, you get 1 by U is equal to minus 1 by V plus 1 by F, and as a result 1 by F is equal to 1 by U plus 1 by V. So, it's a mirror formula. Once again, in convex mirror, a virtual image is formed, but you are getting the same mirror formula. And then let's look for magnification. So, we use that equation number 1 here. We use this equation number 1 here. A dash B dash by AB is equal to PB dash by PB. A dash B dash is plus I and AB is plus O. PB dash is plus V, but PB is minus U. So, the magnification here is I by O is equal to minus V by U, and that's how you have got both the relations in convex mirror. So, the formula remains the same for all the mirrors: concave, convex, real image, virtual image, for any position of object and any position of image. All mirrors you will be using this formula.